Welcome to Homework Lib.
Hi, so over here I'm going to give you two possible answers because in most of the cases for this type of question, you're told to find the balance equation for the full reaction, not only for the half reaction. But let's just focus on what is going to happen to the heptaoxodichromate ion and the chloride ion in this case. So we know that we are going to have a redox reaction. So first of all, my hexadichromate ion, which can be called as well as dichromate ion, remember that it's going to be Cr2O7 with a 2 minus over here. So the charges that we're going to have for chromium is going to be plus 6, and from oxygen, remember that this is minus 2. So for this to sum up to 2 minus, chromium has to be chromium plus 6. And this is going to turn into chromium 3 plus. On the other hand, we're going to have the oxidation of Cl minus that is going to produce Cl2, 0. So we start with Cl minus, we need to arrive to Cl2, and for this we require two negative charges. So now, how do we balance in acidic conditions? First of all, we need to take into account the metals that we have and match up the elements so far, and then what we're going to do is adjusting the coefficients by adding either water, hydrogen, or electrons depending on the other. So the first thing that we need to do, balance the oxygen atoms with the according number of water molecules. So in this case, we're going to require 7 water molecules in order to balance the oxygens on this side. That means that we are going to require as well 14 protons on the left hand side. And now the only thing that we have left is to add up the number of electrons that we require. So chromium went from plus 6 to 3 plus. So that means that per each Cr atom, I need to add 3 electrons for it to go down. So let me make more space over here. What we're going to do is add up 6 electrons over here, plus 6 electrons. And now we're going to do the same over here with Cl minus. We need now 2 extra electrons for this. So now we have the oxidation of Cl minus and the reduction of chromium 6 plus that we have over here. That means that my overall reaction, what we need to do is multiply it by the number of electrons that we have on the other side. So over here we're going to multiply by 2, and over here we're going to multiply by 6. Thus, the overall reaction is going to be 24 H plus 2 of dichromate, 7 2 minus, plus 12 electrons that are going to produce 4 of chromium 3 plus 14 waters. Sorry, here, not 24, 28 protons. Sorry about that. And on the other hand, we're going to have 12 Cl minus that are going to produce 6 Cl2 plus 12 electrons. Notice that the electrons are going to cancel out. 12 electrons with 12 electrons, and the overall reaction is going to be 28 H plus 2 Cr2O7 2 minus plus 12 Cl minus, that is going to produce 4 of chromium 3 plus 6 Cl2 plus 14 waters. And with this, we are done with the problem. You can just verify that the number of atoms balances out, and also the charges, because over here the charges are a little bit harder to see, but in this case we have 28 positive plus 2 negative plus 12 negative. That gives us an overall number of 14 positive. Sorry, here it's 4 negative because we have 2 of dichromate ion. So we have an overall of 12 positive on the left hand side, 12 positive, and on the right hand side as well we have 12 positive. So everything matches up correctly, and we're done with the problem. Thank you very much.